Bismillah Rahman Rahim. Uh, in this lecture of O-level physics course, we will discuss motions or kinematics, and for this purpose we have followed this highly recommended book uh, of Hodder's Educations, and uh, on page 12 we have this question number 1, and here the question is, what is the average speed of a car that travels 400 meters in 20 seconds? So a car travels 400 meters, the distance traveled is 400 meters, and they have time taken 20 seconds. So we will divide the distance traveled by the time taken to get the speed. So this is distance traveled. Distance traveled is 400 meters, so we will write 400 meters, and time taken is 20 seconds, so this is 20 seconds. So 400 divided by 20 means 20 meters per second. So 20 meters and second per second. So this can be write down as 20 meters, and second is in inverse form because this s is in the denominator. Secondly, an athlete who runs 1500 meters in 4 minutes. So we'll write down time travels 1500 meters and time taken 4 minutes, that is 240 seconds. So time travel, distance travel is divided by time taken is the average speed. So 1500 meters divided by 240 seconds. So the average speed is 6.25 meters per second, or 6.25 meters second inverse. Now question number 2, a train increases its speed steadily from 10 meters per second to 20 meters per second in 1 minute. What is the average speed during this time in meters per second? So the increase in speed from 10 to 20, so this is the difference in speed, and time is 60 seconds. So the initial speed was 10 and the final speed was 20. So we will add this and get the average. So this will give us an average speed which is 15 meters per second. So secondly, how far does it travel while the increasing its speed? How far does it travel? So we will multiply this average speed with the time to obtain the distance. So 15 meters per second is the average speed of the traveling, and this time taken is 1 minute, that is 60 seconds. So we'll multiply with this, so we'll have this 900 meters. So this car will travel, or this train will travel 900 meters in 60 seconds, in just 1 minute. A motorcyclist starts from rest. The initial speed is 0. Rest means 0. Initial speed is 0 and reaches a speed of 6 meters per second. And final speed is 6 meters per second after traveling with a constant acceleration for 3 seconds. So he has a 3 seconds acceleration, a constant acceleration. So from 0 to 6 meters second, in 3 seconds he has constant acceleration. So constant acceleration has to find out. So this is A, this is change in speed from 0 to 6. So the initial speed is u, and the final speed is v. So the difference of speed is 6 minus 0, 6 meters per second, and the difference in time, or the time taken, is 3 seconds. So for 3 seconds this is 6 seconds. So 6 meters per second and divide by 3 seconds, 3 divided by 2 meters per second. The average constant acceleration is 2 meters per second. So in first second, from 0 to 2 meters per second, and then again 2 meters per second acceleration means, and after 2 seconds it will be 4 meters per second, and after 1 more second it will be 2 meters per second acceleration with 6 meters per second. So we can easily understand that from 0 to 6 meters per second. In first second it will reach 2 meters per second. After 2 seconds it will be 4 meters per second, and after 3 seconds it will be 6 meters per second. So this is very easy. We can understand that how it's working. So this is the acceleration that has to be find out, that has been asked in this problem. So a motorcyclist then decelerate at a constant rate for 2 seconds. After reaching this 6 meters per second, this motorcyclist is decelerating at a constant rate for 2 seconds. So for 2 seconds it decelerating and decelerate to reach a zero speed. So what is his acceleration? Now the difference is 2 meters per second, and the time taken is 2 seconds. So his deceleration is 3 meters per second square. So after 1 second it will reach 3 meters per second, and for the next second it will reach 0 second in a rest condition. So eventually this is 3 meters per second square. This negative sign indicating that this speed is decelerating. Speed is decreasing. An aircraft travels at 600 kilometers per hour, accelerates steadily at 6 kilometers per hour per second. So the initial speed is 6 kilometers per hour, and it accelerates every second. Its speed is 10 kilometers per hour increasing. So after 1 second it will reach 610. After 2 seconds 620. So in this way it will reach 1100 kilometers per hour at the aircraft's altitude. Taking the speed of the sound as this at the aircraft's altitude, how long will it take to reach the sound barrier? So we have initial speed u 600 kilometers per hour, acceleration is given as 10 kilometers per hour per second. So here we have 2 times. This is speed and this is change in speed per second. This speed is changing every second. So the speed of sound is 1100 kilometers per hour, and we have to find the acceleration. So eventually this final speed, this sound barrier speed, is the final speed the aircraft has to achieve, 1100 kilometers per hour, and this is 600 initial speed of the aircraft, and time taken has to find. This time taken has to find. With the acceleration is given as 10 kilometers per hour per second. So this acceleration is given, and we have to find this delta t. So in this acceleration we will place this value here and we'll find this delta t. So this delta t has to be placed here, and this a will be appear here. So this 10 kilometers per hour per second means this kilometers per hour, this is 500, this difference is 500 kilometer per hour, this is 10 kilometer per hour per second. So this kilometer per hour, this kilometer hour will cancel out, this second in the denominator will appear at the numerator. So this is this. So 500 divided by 10 is 50 seconds. After 50 seconds this aircraft will reach 1100 kilometers per hour, because this every second 10 kilometers is increasing. So 10 kilometers increasing. So after 50 seconds the speed will be 500 kilometers per hour increase. So 600 plus 500 kilometers per hour is 1100 kilometers, which is also easily be understand by simply taking this value. So we can understand how the actual phenomena is occurring. So eventually after 50 seconds, if the acceleration is constant with this format, the speed, the aircraft will reach the sound barrier at 50 seconds. Now test yourself, page 15 of the book. Here we have the speed of a bus traveling on a straight road are given below at successive interval of 1 second, and the time is 0, speed is rest 0. After 1 second, speed is 4 meters per second. After 2 seconds, speed is this, 3 seconds 12. After 4 seconds, speed is 16. So speed is increasing, means acceleration is there. Here we have a speed curve or a velocity curve and time, speed and time. So this curve is drawn like this. So at t0 0 we have this point, at 1 4 this is 1 time and this is 4, 1 4 this is 2 and this is 8, this is 3 and this is 12, this is 4 and this is 16. So this is increasing. So here we have the acceleration, constant acceleration. Now choose the two of the following terms which describe the acceleration of the bus. Acceleration is increasing, means, and constant. Here acceleration 4 meters per second, here in the second 1 to 1 or here to here, the difference is 4, here the difference is 1. So in 1 second 4 meters per second, here 2 to 3 1 second difference, here the speed difference is 4. So 4 meters per second in 1 second. So the acceleration is constant. So this is constant, acceleration is constant, and acceleration is increasing. So positive. So this positive and constant. So choose two of the following terms which describe the acceleration of the bus. So it is constant and positive. So acceleration is 16 by 4, 12 by 3, 8 by 2, 4 by 1. All is 4 meters per second. Calculate the acceleration of the bus. Here the acceleration is 16. This is 16 divided by 4. So this is 4 meters per second. Calculate the acceleration of the bus. Acceleration of the bus is this. So it's from 0 to 16 and divided by time. Overall time is 4. So this is 4 meters per second. Here same. But in this way we are seeing that we can observe the acceleration is constant throughout. Finally the acceleration is this, and at every instant the acceleration is same. So this is uniform acceleration, uniform constant acceleration. This is the end acceleration, and this is uniform every instant. After every second the acceleration is same. So this is called uniform acceleration as well. Calculate the area under your graph. So under the area under the graph is this. So this is area under the graph. This is time, and this is. So this is the base, and this is the height and half. This is because this is the area of the triangle. So this is base, this is height and half. So half, this time axis 4 and the vertical axis is 16 magnitude. So this is 32. How far does the bus travel in 4 seconds? So this 32 is basically if under area curve of the speed time curve, it gives the distance. So the integration or the area under curve is basically giving the distance. So the bus travels 32 meters in 4 seconds, and average speed is basically 0 to 16 divided by 2 is 8 meters per second. And if we multiply this 8 meters per second with 4 seconds, we get this 32 seconds. This is another way you can see this. Now question number 6. The distance of a walker from the start of her walk is given below at successive interval of 1 second. Here we can see someone is starting, she is starting from 0 0. So at time t is equal to 0, the distance is 0. She is in the rest state, and after 1 second speed she travels 3 meters. After 2 seconds 6, after 3 and 7, eventually after 6th second 18. So we can plot it here, 0 plot, After 1 second, 3. After 2 seconds, 6. After 3 seconds, 9 meters. After 4 seconds, 12 meters. After 5 seconds, 15 meters. After 6 seconds, 18 meters. So this is time and this is distance. We have plotted it, and this is the first part. Second part, how would you describe the speed at which she walks? She is because this is distance and this is time, the speed is constant. In 1 second she travels 3 meters. In the next 1 second, from 1 to 2, she also travels 3 meters per second. From 6 to 9 in this duration, she also travels 3 meters per second. So the speed is constant. So speed is constant. Calculate her average speed. Her average speed is distance traveled divided by time taken. So she traveled 18 meters and time taken 6 seconds. So 18 meters divided by 6 seconds is 3 meters per second. And now use this figure to determine the acceleration at a time 1 second. So at a time 1 second, acceleration is basically this is the point where we find the change in speed. So at this 1 second, we have the delta V is 17.5 meters per second. At this is equal to 1 second, this is 17.5 meters per second. So the delta V divided by delta T is 17.5 meters per second. Now put this into practice. 16. An athlete acceleration from rest is at a constant rate of 0.8 meters per second square for 4 seconds. Calculate the final speed of the athlete. So initial speed is 0 and the constant rate of acceleration is given, A is equal to 0.8 meters per second, and time for 4 seconds is given, and it has to calculate the final speed. So final speed is given by V is equal to U plus AT, because the acceleration is equal to V minus U divided by T. So this AT is here and V is equal to U plus AT. So in place of U we have this rest state 0 and acceleration is 0.8 meters per second and the time is 4 meters per second. So this is 3.2 meters per second. So the final speed is 3.2 meters per second under this given conditions. A cyclist increases his speed from 10 meters per second to 20 meters per second in 5 seconds. So this is duration of time is 5 seconds, and he's changed his speed from 10 meters per second to 20 meters per second. Calculate his average speed over this interval. So we have to add this and divide by 2 to get the average speed. So average speed is 10 plus 20 divided by 2 is 30 meters per second, divided by 2 is 15 meters per second. So this is the average speed she travels. Now calculate the distance moved by a car accelerating from rest at a constant rate of 2 meters per second square for 5 seconds. This is a superscript, this is typing error, s square. So initial speed is u is equal to 0, acceleration is 2 meters per second square, and time is 5 seconds. This is 5 seconds. So the s is equal to average speed multiplied by time. So we also have this v is equal to u plus at. This is at. So t is here, a into t. So this u plus at. So u plus at. So this is t divided by 2. So this u plus u is 2u plus divided by 2, and this is at divided by 2, and this t is multiplied with this one and this one. So it's ut plus half at square. So initial speed is 0. So this is 0. So this is 0. So t is here, half a and t square. So t square is basically 5 seconds. This is 5 seconds. So in place of t, square, we have 5 seconds, and this acceleration is 2 meters per second square. This is given. So this is 2 meters per second square. So s is equal to, this is 0, and this is, we have, so this 2 into 2 cancels, and this 5 squares becomes 25. Here the unit is meters per second square, is second square, so this unit will be appear as a meters. So this is 25 meters. So the distance traveled is 25 meters. So for this, calculate distance moved by a car accelerating from this to this after this 5 seconds will be 25 meters. So this is the answer. For this page 90, we will consider in the next video.